Okay, we were talking about the error form. Okay, look, if you remember when we talked about the errors, we have first the accurate error and an approximation of the error, if you remember. Okay, the exact error is for the composite trapezoidal rule is minus 1 over 12 f second epsilon times b minus a cube. Okay, but we said that this psi or epsilon is unknown. So this is why we did further derivations to come up with a more useful form for the error. And this is the form that I will give you. I will give you this, not the other one, because you don't know where is psi. So a better approximation for the error is the following one. E equal to minus b minus a cube over 12 and square times f second average. Okay, and also this f second average, we cannot know it exactly. We can do an approximation for it. And this is why we say we'll do the approximation of the error as minus b minus a cube over 10, 12 and square times f second average. Because f second average we can calculate, but f second bar we cannot know it since it's depend on psi. Okay? So when I give you this, what can you conclude from this? First, the first conclusion is that the error is proportional to the second derivative. So we have, when we have x squared, x cubed, etc., we have an error. Okay. Another conclusion is that when we the error is inversely proportional to n squared, to the number of segment squared. Okay, so when we double the number of segments, then we expect that the error will be divided by 4, approximately, of course. Okay, so this is why giving you this will allow you to say that if I double the number of segments, and we consider this, let's say when we write I1, this means we are using one segment. When we write I2, we are using two segments. I4, 4 segments. Okay. So you can say automatically that I2 over I1 is equal to the error in computing I2 over the error in computing I1 is approximately equal to 1 over 4. Okay, why? Why I say approximately first? Because as we said, we don't know how to calculate this exactly. We want to get an estimation for it. So we estimate it as a second average. So when you do the ratio, and if you take the first error is b minus a cube over 12 and 1 square times f second average. While the error when you compute I1 is b minus a cube over 12 and 2 square times f second average. So you can see here that we can simplify this b minus a cube, and we can simplify f second average and 12. What do we get? We get just that I2 over I1 is equal to N2, the error, of course, error of I2 over error of I1 is equal to N1 over N2 square. This is why we say in the trapezoidal method, if we double the number of segments. If you consider when we double the number of segments, this means that we are taking the particular case of n2 equals to 2n1. So when we double the number of segments, we can always say that each time I double, the error is divided by 4. Because if I replace here, I will get error of I2 over error of I1 is equal to 1 over 2 square, which is equal to 1 over 4. Okay, but of course, if I don't double, this is only when I double the segment. If I multiply the number of segments by 4, then it will be 1 over 4 square. Okay, so I need to know how I am going from if I'm doubling the number of segments or if I'm multiplying by 3 or by 4, etc. Okay, so this expression will help me into knowing what is the relation between the error in two consecutive steps. Okay, so going back to our problem. So they are telling us here, and if we use the composite trapezoidal rule, the first correction will give us this. But let us derive it together. How we got this expression? All we have to say is to relate the errors. And now if I write the error I1, which is the integral using a certain number of segments, plus error E1 should be approximately equal, because what I am doing, I am computing the integral. So the first method using just a certain number n1 of segments, and then when I use n2, I get I2 plus E2. Okay, but now together we have seen a relation between E1 and E2. We said that error E1 is equal to 4 times, because when we do 2 square, it's 4 times E2. So we can replace in this equation, we can replace the error E1 by 4E2. So then we get I1 plus 4E2 equals to I2 plus E2. And now we can get a certain approximation of the error, because we can get the expression of E2. What is E2? We have that 3E2 is equal to I2 minus I1. Sorry, 1 second. Okay, and now once we got an expression of the error too, how we can compute the integration instead of just saying that we have an error that we don't know what is the value of it, we can just say now the integral can be approximated in a much better way, because instead of saying I'm just getting I2 and I don't know what is the error, I am approximating this error. So my integral now will be equal to I2, and I will replace E2 by its value, which is from here I2 minus I1 over 3. So plus I2 minus I1 over 3. Okay, and now you can get what is I when you do the first Richardson extrapolation, the first correction. You get that I is approximately I2 plus 1 over 3 I2, so 4 over 3 I2. Plus minus 1 over 3 I1. Okay. And when we say 2, 1, here we mean that we are using one segment. Here we are using two segments. I42 is a Richardson extrapolation you can get from using an integral using two segments with an integral using four segments. And I84 is the one using combination of integral using 8 segments and 4 segments. As you can see, we are doubling the number of segments. This is why we are using 4/3 minus 1/c. Okay. Now, this is the first correction. Okay. So for the first correction, the order of errors, the error for composite trapezoidal rule is proportional to h squared, as we have seen in its expression. Okay. Now, what we will do, what is more challenging, is to do the other corrections, because each time we do a Richardson extrapolation, we gain 2 orders of accuracy. Yeah, the error, when you do the first extrapolation, instead of having error order h squared, the error will become proportional to h4. Okay, and each time you do a new Richardson extrapolation, you will gain 2 additional order of accuracy. When you do it a second time, now the error will be of order of h6. Why we are saying that? How we use this? If you remember, when we got the error expression for the trapezoidal, for the composite trapezoidal rule, okay, going back to its expression, we have here we have n squared. Okay, and the order here is square. This is why we say it's proportional to h squared. Now, increasing the order of accuracy, because we did a Richardson extrapolation, instead of having order square, we have now order 4. So this is why when we do the ratio of errors now, instead of having to the power 2, we'll have to the power 4. So the expression will be very similar, but now instead of having n squared, we'll have n4. And this is why when we do the next Richardson extrapolation, we should update the coefficients. We cannot anymore use 4/3 and 1/3. Okay, we use it when we do the first Richardson extrapolation, because the error was of order h squared. Because in the trapezoidal, composite trapezoidal rule, the error is of order h squared. But once we do Richardson extrapolation, we always gain 2 order of accuracy. And you are not responsible of the derivation, just you should know this. And whenever I apply Richardson extrapolation, I gain 2 order of accuracy. So instead of having the error order h2, now the error will be of order h4. And this is why the ratio of errors, and if I consider h21 over error h42, then it's approximately equal to the ratio of h to the power 4. And we know that we are doubling the number of segments, so the ratio of h is 2. Okay, so now in the new Richardson extrapolation, the ratio of error, instead of being 2 squared, it's 2 to the power 2 plus 2, because we gain 2 order of accuracy using the first Richardson extrapolation. And now we do exactly the same technique to get an expression of the coefficient. And how we get the new coefficients? We repeat the same method. We write, now we are using 2 consecutive integrals after the Richardson extrapolation. So h21, integral using h21, this means this is the integral using I1 and I2. Okay, so it means I21. So I21 plus the error involved in I21 is equal to I42 plus the error involved in I42. Okay, so now, exactly as we did in the previous method, we want to compute the error. We need to get an approximation of the errors. This is why we can replace here the error h21, okay, by its expression from here. It's equal to the error h42 times 2 to the power 4 now, instead of 2 to the power 2. So we can replace this by error h42 times 2 to the power 4. Okay, and then, as we did in the previous case, we do the development and we can write an approximation of the error. This is the approximation of our error. And then if you find the coefficients, okay, you get that the coefficient of I42 is 1 plus 1 over 15, which will give you 16 over 15. Okay, so this is why when you do the second Richardson extrapolation for the trapezoidal method, you get 16 over 15 I H42 minus 1 over 15 H21. Okay, and the third, if you want to do Richardson extrapolation a third time, also you have a similar method, but you should pay attention that always, whenever we go from one stage to the other, we are gaining 2 order of accuracy, so plus 2. Okay, so this is why each time we do a new step, we should update the coefficients. To understand better, I will show you the scheme for this. This is the scheme. Okay, so first you do the composite method, trapezoidal method, as we know before. You consider, let's say, because we are doubling the number of segments, we have 1, 2, 4, 8 segments. Okay, you compute the integrals as you know how to do it using your formulas. Now, when you want to do the first Richardson extrapolation, okay, you combine each two. You combine, for example, I1 and I2, you get I21. You name it I21. And then you combine 2 and 4 to get I42. So this is I42. And you combine 8 and 4 to get I84. Okay, and since here you are combining results from the composite trapezoidal rule, then the coefficients are 4 over 3 and 1 over 3, because it's the first time you are doing the Richardson extrapolation. Okay, now once you are done with this and you move to the second Richardson extrapolation, and now you are using, for example, you are using I21 and I42. The combination of them, you can name it I4221. And sometimes, because 2 is you are repeating 2, they put it I421. Okay, so they combine. If you want the numbers you are using to do the Richardson extrapolation. So this is I421 and this is I842. Because you are doing the Richardson extrapolation for the second time, you should pay attention that the order is not anymore 2, it's 4. This is why the coefficients that you should use to compute these are the one we derived now, 16 over 15 and minus 1 over 15. And now if you want to do it a third time, if you want to combine these two and do it a third time, you should increase the order. This is why you should find the new coefficients. And then you can see the derivative here. Again, same procedure always. You start by writing that I am getting the integral using H421 plus a certain error that I don't know is equal to the integral using H842 plus an error that I don't know. But what is good is that I can correlate these two errors. I know that I gain 2 order of accuracy. So now I can replace the error of H421 by 2 to the power 6, 2y2 because I'm doubling the number of segments, and y6 because initially the order of it's order of h squared. Okay, then I did the Richardson extrapolation a first time, I gained 2 order of accuracy, and now I did another time, I gained 2 other orders, so now the order is 6. So it's 2 to the power 6 times error H842. Okay, and now all you have to do is to replace this term by 2 to the power 6 times error H 842, then you can get an estimation of this error. Okay, and then finally you can write, if you want, let me do it for you in detail. Okay, you will get the following. You can, if you replace, you will get that error 842 times 2 to the power 6 minus 1 is equal to integral using 842 minus integral using 421. Okay, so now what is your error? You have an approximation for your error. It's I842 minus I421 over this number, 2 to the power 6 minus 1. So you get 63. This is 63. Okay, so now if you replace the error by its expression, which is here, okay, then you can find that the coefficient of the integral A42 is 1 over 63 plus 1, which is 64 over 63. And the coefficient of integral H421 is minus 1 over 63. And in this way, you derived, after 3 Richardson extrapolations, what should be the coefficients used. Okay. Any question on this? Okay, look, if you have any other question, you can contact me anytime, okay? Good luck. See you tomorrow. Bye.
Thank you, doctor.
Yes.
سؤال نحن هلا طلعنا بالبروبلم اللي فوق طلعنا الديريفيشن لل 1 over سيمبسونز 1 over 3 ل 3 over 8 بنعمل نفس الشيء بس بنزيد
point. Yes, exactly. Instead يعني بدل ما تكون 2 points بتصير، بدل ما تكون 3 points بتصير 4 points، يعني بتصير الorder cube instead of square.
Okay, thank you.
Welcome.
دكتور
Yes.
في أسألك سؤال هون.
Sure.
في عزبك تفتح الأسايمنت 5.
Yes. Yeah, 1 second. Yes, Charles, tell me.
فيك تنزل آخر سؤال problem 6.
Yeah.
بس عندي السؤال بالRK4.
Yes, tell me.
هن عطينا إنه ال H بالRK4 0.05.
Yes.
طب نحن أول شيء إنه جبنا K1 لل 2 equations.
Okay.
بعدين بالK2 مش لازم نجيب الميد بوينت هنا، إنه مش لازم نستعمل 0.05 over 2. ما بعرف إذا هون غلط أو أنا فاهم غلط.
Okay, look, I will check it for you and send you my response, okay? خليني أشوف على المظبوط شعرين and I will tell you. Any other question?
لا دكتور.
Okay. Yeah,
Thank you.
bye. Welcome, bye.
Bye.